3-eye atlas. And yes, we've got some updates. Check out these new images that show 3-eye atlas in a whole new light. What's going on with this situation?
What do you call an object moving faster than 100,000 miles per hour? That stops drifting mid-space, mimics spacecraft, and then vanishes from thermal view like it was never there. The Pentagon didn't just flag it, they sealed the images. The orbs aren't orbiting, they're in perfect formation. And what happened next has top analysts whispering. This isn't just another comet story, this is something else, something deliberate. The Pentagon lockdown, why the new images were classified. For 3 straight days in mid-November, something strange happened inside the Department of Defense that even career analysts whispered about. The newest high-resolution sets of 3-eye atlas images, captured by sensors on military-grade telescopes that normally track classified satellites, were abruptly sealed. Not delayed, not under review, sealed. Logged under a category known internally as transient luminous non-drifting bodies.
From images, we also saw that this object is active, which is an indication that this object is in fact a comet.
That label has never been used for a comet, asteroid, interstellar object, or anything appearing in an astronomical catalog. It is typically associated with objects that maintain rigid positional stability, the way an active satellite would if it was station-keeping in orbit. Except 3-eye atlas is moving at hyperbolic escape velocity, on a path that no satellite can possibly track. And the orbs around it aren't in orbit at all. They're in formation. What triggered the Pentagon's lockdown was not the brightness, not the color, and not the spherical transformation. It was the lack of drift.
To the best of his ability, as I think you know, it's still an active scene. There is an ongoing investigation.
According to internal analysts familiar with frame-to-frame comparisons, the new images captured at least 3 smaller luminous bodies holding perfect angular separation from the main object over intervals where natural dust, ice, or debris would shear apart like confetti in a hurricane. In fact, one fun fact, even a 1-meter ice fragment exposed to solar radiation pressure would drift roughly several kilometers per hour relative to a primary body. These orbs drift 0. That is why the Pentagon flagged them. Another detail leaked through defense industry insiders. The classified frames recorded persistent luminosity lines, meaning the orbs maintained their brightness even as background stars shifted. That rules out cosmic rays, hot pixels, sensor artifacts, or transient reflections. You don't classify a camera glitch. And here's where theories began exploding. Some astrophysicists quietly compared the formation to NASA's own autonomous swarm satellite experiments, where multiple drones maintain synchronized positioning through AI feedback loops. Others pointed to a similarity with solar sailing microprobes, which use radiation pressure to stabilize orientation. But the most controversial theory came from international analysts, that the orbs might be engaging in passive gravitational coupling, a behavior predicted in theoretical self-assembling probes that use microforces to maintain group cohesion. Then came the kicker. 2 intelligence sources claim the DoD's orbital dynamics team reported an abnormally low positional jitter, less than 1/10,000th of a degree, across multiple exposures. That kind of stability does not exist in natural fragmentation, especially not from an interstellar object traveling faster than 100,000 miles per hour. Behind the scenes, this combination of non-drifting, formation stability, and persistent luminosity triggered the Pentagon's fastest classification action since the 2019 Navy UAP footage.
We're all going against the wind. The wind's 120 knots from the west. Look at that thing, dude.
The Lagrange echo theory. Are the orbs shadowing 3-eye atlas from pre-planned points? One theory quietly gaining traction among high-level orbital physicists is called the Lagrange echo hypothesis. The idea that the orbs around 3-eye atlas aren't random companions or chunks of ejected material, but are instead deliberately stationed at mathematically precise points relative to the object's path, functioning like relay nodes. And if that theory is true, it would not just reclassify them, it would redefine them.
This is the trajectory right here. It's kind of close to Mars, but not really, but it's still pretty far away from Earth.
In celestial mechanics, Lagrange points are regions of orbital equilibrium where a small object can remain stable under the gravitational pull of 2 larger bodies, like Earth and the Sun. The fascinating twist? If 3I Atlas is an engineered object, then the orbs could be maintaining artificial Lagrange-like positions, micro-stable zones not tied to planetary systems, but to the object's own inertial frame. That would explain how they maintain perfect formation without visible propulsion. It would also suggest they are not just passively flying, they are strategically deployed. Some astronomers point to a pattern in the spacing of the orbs, 120-degree separations, just like the L4 and L5 Lagrange points in planetary systems. If this pattern holds, it would not only rule out natural clustering, it would imply positional planning. Even more curious, one analyst on the ESA's JUICE mission reportedly found phase-matching echoes between 3I Atlas and one of the luminous points using low-band radio noise comparison, almost as if the main object and its companions were relaying data between each other via tight electromagnetic handshake loops.
L1, L2, and L3 are on the line connecting the two bodies.
Fun fact, in the late 1990s, both NASA and ESA proposed an experiment called SIMBA, Solar Interferometry Mission for Baseline Alignment, where artificial satellites would maintain ultra-precise spacing in deep space using Lagrange-style tethering. The project was shelved due to instability risks, but the math remains in the literature. Some now wonder if we're seeing that same idea already in practice. Another eerie parallel comes from Voyager 1's spin anomalies in 2023, minor course jitters that were written off as system glitches. But a reanalysis of its 2023 telemetry showed slight directional pings, faint signals with no known source, arriving precisely in the direction 3I Atlas would later approach from. Is it a coincidence? Or was something already scouting the route? What if these orbs aren't drifting because they're stationed, like buoys, not to follow the object, but to announce it? The frequency that shouldn't exist. Deep space anomalies nobody is explaining. While telescopes were chasing light, a handful of radio observatories were listening, and what they detected has become one of the strangest, least explained anomalies tied to 3I Atlas. On October 22nd, just as the object approached solar conjunction, the Allen Telescope Array, ATA, in Northern California, logged a narrowband spike in the 1420.405 MHz range, also known as the hydrogen line, the universal quiet zone, where interstellar communication is most likely to be heard. This frequency is protected worldwide because no natural astronomical source emits it strongly outside of cosmic hydrogen. But that day, for 11 continuous minutes, a spike was recorded from the exact RA-DEC coordinates of 3I Atlas. Now here's what makes it even weirder. The signal was not drifting in Doppler space. For an object moving at over 130,000 miles per hour, any natural signal should stretch or compress due to the Doppler effect. But this one held constant, implying either it was artificially compensated or emitted from something that wasn't moving with the main body. SETI researchers flagged the spike internally but made no public announcement. However, a leak from a technician on the ATA's back-end data team revealed the spike carried an unexpected phase modulation signature.
Radio astronomers worldwide start to come up with this concept for the next week.
Not random static, not Morse-style blips, but a smooth sinusoidal pattern that repeated exactly every 1.47 seconds. Not only is this not typical of cosmic events, it's uncharacteristic even for known spacecraft beacons. More shocking, the exact same frequency blip was reported 6 days earlier by an amateur radio astronomy group in southern Italy, using a home-built parabolic dish setup tuned for hydrogen line listening. When the raw IQ data from both sites was compared, the timing, spacing, and amplitude matched perfectly, down to the millisecond. Experts tried to rule out Earth-based interference, but neither location had overlapping satellite coverage, and the windows matched the object's exact sky position. NASA has not acknowledged the reports. AARO has declined to comment, but leaked metadata suggests that 3 more listening posts across the globe, one in South Africa, another in Western Australia, and one in Japan, quietly logged matching anomalies within that same week. Some are calling it a coincidence.
The data came from US government satellites. Maybe it was not a meteor, maybe it was a truck.
Others say it's a beacon test. A growing fringe theory suggests we're not watching the orb, it's watching us, broadcasting on a frequency known to reach across galaxies, deliberately choosing the one channel the entire universe would know to monitor. The infrared blackout. Why 3I Atlas should glow but doesn't. When a body swings close to the sun, it doesn't just shine, it boils thermally. That's why every known comet, asteroid, and interstellar rock emits infrared radiation, a glow that reveals its temperature, surface activity, and even internal structure. But 3I Atlas, for all its strange visual behavior, did something far more impossible. It went cold, at least in infrared. Between October 30th and November 2nd, NASA's NEOWISE telescope, operating in the mid-infrared bands, ran a scheduled scan as 3I Atlas rounded perihelion. At that range, just a few million miles from the Sun, any natural body should be emitting strong IR signatures, especially if it's undergoing the kind of rapid transformation seen in visual wavelengths.
Right now, a fleet of NASA spacecraft are turning their attention to an unusual object through our solar system.
Yet according to sources familiar with the scan logs, the thermal signature was nearly flatline. Not dim, not faint, missing. A frozen rock under solar bombardment, thermally silent. NEOWISE data showed the background sky glowing as expected, but 3I Atlas's core returned readings less than 1/10 the predicted IR flux, lower even than known metallic asteroids, which are famous for high reflectivity and low thermal inertia. Engineers initially suspected an instrument glitch until NASA's airborne SOFIA telescope, on a separate run in the upper stratosphere, logged the exact same thermal anomaly. The object had reflectivity, it had mass, but it did not glow with the heat it should have been absorbing. This is not a minor quirk. According to NASA's own comet thermal models, for the object to appear visually bright yet radiate almost no IR heat, it would need to be wrapped in a metamaterial shell.
We would like to understand better what the size of this object could be, the composition, the levels of activity.
Something capable of redirecting or scattering thermal radiation away from Earth-based sensors. This technology is theoretical for human spacecraft, but the math checks out. The implications? Even if the orbs are somehow natural, the core object itself may be cloaked thermally, behaving like a mirror for heat. Some classified DARPA proposals from the early 2000s explored this very concept under the codename black-body dampening cloaks, a way to shield objects from detection by infrared satellites using advanced lattice phase materials. Nothing was ever built, but 3I Atlas appears to be doing it effortlessly. Thermal suppression without cooling? That's not just unlikely, it's unearthly. So the question is no longer just what it is, it's how does something heat up and vanish from the spectrum anyway? The magnetosphere twitch. Did Earth flinch when 3I Atlas passed?
I think this is a wonderful topic, and there are many other scientists who are just working on the details of what it takes to make us healthy.
On November 6th, as 3I Atlas quietly exited solar conjunction and re-entered visibility from Earth, something strange happened. Not in the sky, but deep within the Earth's own protective bubble. At 4:19 a.m. UTC, multiple magnetometers from the Intermagnet Global Network picked up an anomalous micropulse, a sharp, localized fluctuation in the Earth's magnetic field, detected across stations in Brazil, South Korea, and Sweden. The pulse lasted just 1.6 seconds, but it was strong enough to trigger anomaly flags across independent observatories. No solar storm was occurring, no coronal mass ejection, and no recorded geomagnetic trigger, natural or otherwise, could explain it. Initially, scientists chalked it up to instrumentation noise, until it turned out that all three sites recorded the spike at the same time, adjusted for latency. And the real kicker? The vector angle of the magnetic perturbation, when triangulated, pointed directly toward the coordinates of 3I Atlas as it emerged from behind the Sun.
We've got some fresh images of 3I Atlas, a third ever interstellar object observed from Earth.
Now here's where it gets eerie. Objects in deep space should not be able to influence Earth's magnetosphere, unless they emit extremely high-frequency electromagnetic fields, or unless they generate temporary magnetohydrodynamic effects via charged particles. But 3I Atlas was never recorded releasing a flare, beam, or ion trail. There were no solar interactions reported in the heliophysics logs, and yet the magnetic impulse was real, global, and directionally consistent. A quiet paper posted to arXiv.org by an Eastern European research team noted that the pulse's phase profile looked suspiciously like a low-frequency ELF burst, a type of electromagnetic wave typically generated by powerful electrical discharges or artificial transmitters. These are the same kinds of signals studied in Project Sanguine and HARP, where ELF pulses were once theorized to communicate with submarines, or even to manipulate atmospheric density. And it gets weirder. Researchers reviewing archived VLF data from Antarctica spotted a similar click pattern burst on August 12th, the day 3 I-Atlas crossed Earth's orbital plane. Again, no other space weather events were logged. Is it possible the object is pulsing something we can't yet interpret?
This is the first time something like that is observed, where there is a glow ahead of the object towards the sun.
Some researchers now speculate that the orbs aren't just traveling with the object, they may be instruments.
There's a mysterious interstellar object hurtling towards our solar system, exciting scientists across the globe.
Scanning, pinging, or testing Earth's magnetic defenses. Because here's the thing, the magnetosphere has one job: keep out everything unnatural. But on November 6th, for less than 2 seconds, it twitched. The Mimicked pattern. Is 3I Atlas copying known spacecraft behavior? What triggered quiet alarms among veteran spacecraft analysts wasn't just how 3I Atlas looked, but how it moved. Since July, the object has shown a peculiar navigation pattern, brief adjustments in trajectory that resemble station-keeping behavior, not the free-fall arcs of natural gravity-bound bodies. But a deeper layer of the mystery emerged in October when researchers noticed something truly disturbing. 3I Atlas appears to be mimicking the velocity profile of past Earth-launched spacecraft. Let that sink in. It's not just drifting, it's following known orbital flight logic. A private orbital mechanics team from Germany, cross-referencing historical telemetry data, noticed the object's post-perihelion arc matched Voyager 2's 1981 escape profile, including the slingshot curvature as it passed Mars. The math showed a trajectory overlap of 97.8% when adjusted for speed and solar proximity. That alone could be coincidence. But then came a second match. When plotted against ESA's Rosetta mission, which famously rendezvoused with Comet 67P in 2014, 3I Atlas showed a near-identical gravity assist pattern across 3 planets, Mars, Earth, and Venus. Only Rosetta's path was meticulously calculated over years. 3I Atlas, it just drifted into it. NASA's internal simulations showed that for this object to accidentally follow 2 of humanity's most complex multi-body trajectories, the odds would be 1 in 8.7 million.
The object's path appears intelligently directed, and he suggests that we should have a risk assessment scale in place.
And yet the mimicked arcs are there, pixel for pixel, day for day. That's when some theorists began asking an even harder question. Is 3I Atlas observing us and practicing? Some call this behavioral convergence, a term used in military defense when drones are suspected of reverse engineering the flight paths of friendly aircraft. But this has never been observed with interstellar bodies. Never. Now fast forward to early November. A fringe analyst spotted something even more unsettling in the raw orbital prediction data from JPL's Horizon system. On November 3rd, the object made a minor mid-course correction, enough to slightly alter its ecliptic departure angle.
We cannot really pinpoint the nucleus size. It's partially due to the size of the object, but also it's partially due to the activity.
The final arc now mirrors the 1977 exit vector of Pioneer 10, the first man-made object to leave the solar system. Not just similar, identical within 0.2 degrees. The polarization cloak. Is 3I Atlas bending light to hide its shape? One of the quietest but most unsettling discoveries tied to 3I Atlas isn't about its speed or its orbs. It's about how it reflects light, more specifically, how it polarizes it.
3I Atlas comes back into view. Right now, it is hidden behind the sun. And during its closest approach, Earth-based telescopes are not going to be able to see it. What's worse,
when light bounces off natural surfaces in space, dust, rock, ice, the reflected light shows a predictable polarization pattern. This is how scientists determine the shape, texture, and even the rotation of distant asteroids and comets. But not with 3I Atlas. During a campaign led by the Crimean Astrophysical Observatory, a team using a dual polarization spectrometer noticed that the object's reflected light, instead of showing linear polarization consistent with an icy or rocky body, showed circular polarization, meaning the electric field of the light twisted as it reflected. That kind of twist doesn't happen naturally unless you're looking at highly structured or engineered surfaces. The team repeated the observation using different filters and orientations. Same result? Even worse? The degree of circular polarization varied depending on viewing angle, as if the object was actively adjusting its surface properties. That's not something ice does. That's something smart materials do. Materials designed to reflect incoming energy in a controlled direction, like adaptive camouflage. You may have heard of stealth skin, metamaterials being developed for aircraft and drones that scatter radar or infrared to appear smaller or vanish entirely from detection systems. But what if 3I Atlas is doing the same, with visible light? One MIT scientist, speaking off record, said the object's polarization signature looks exactly like field-tested metaskin prototypes, except magnified to an impossible scale. The most compelling clue? In multiple observations from Spain and Hawaii, astronomers recorded brief polarization nulls, tiny moments where the object's brightness dropped only through polarization filters, but not to the naked eye. That suggests active phase cancellation, a technology used in advanced optics to mask shape and material edges. In other words, it's not just glowing, it may be deliberately scrambling how we see it. Even comets with extreme spin or jetting behavior don't do this. Polarization anomalies of this magnitude are rare even in laboratory conditions. Tap the card, subscribe, and tell us your theory below.